Hello friends, welcome back to Ekeeda. In the previous lecture, we have solved a problem based on the final settlement, and also we have seen how to find the pore water pressure and the effective stress at different stages of consolidation. Okay, now let us move forward. What is there in the question? So let us first understand. A reclamation site for which soil strata is shown in the figure. A 3-meter layer of a fill material is to be laid instantaneously on the top surface. Okay, that means there is a sanded type, silty sand and clay. Over of this, they are placing some fill material. If coefficient of volume compressibility, that means volume compressibility of the clay layer is given. So what they are asking? They are asking consolidation settlement of the clay layer due to the placing of fill material. That means because of this fill material, we have to find out what is the settlement that can occur. Now, if you see in the question or if you see in the data, we know only the weight densities. We don't know about liquid limits, or we don't know about compression index, or we don't know about the void ratio. Nothing we know, isn't it? But from the given data, we know that we know only the volume compressibility. So, from the volume compressibility, can you write it down any formula such that we can have the settlement layer? So if you recall the formulas, this we can write it down as either delta E by change in effective stress, or we can write it down as delta V by change in effective stress. As cross section is constant, we can also write it as delta H by H divided by effective stress delta sigma dash. That means here delta H is nothing but the settlement. Then what about change in effective stress? Effective stress is changed because of this fill material. So what will be the change in effective stress? That will be equal to, because of this fill material, what is the density? That is nothing but a 3 into 21. That means 63 kilonewton per meter square. That's it. Substitute on the relation. That implies, what about the volume compressibility? Given as 2.2 into 10 to the power of minus 4. That will be equal to, change in settlement is nothing but a delta H divided by, what is the clay layer thickness? 10. If you look here it is in meter square. That's why I am substituting each value in meters. Otherwise, we have to convert them. Divided by, here the forces are in kilonewton. So here it is also kilonewton. So no problem. Change in effective stress is 63. So if we solve this problem, then we will get the settlement of the clay layer, or we can say it is a change in thickness of the clay layer. Either it may be a change in thickness or it may be settlement. Both are represented by the same. So here it is contrary to the problems whatever we have discussed. As of now, we have seen the problem. Those are using compression index. So this is the problem that is based on the volume compressibility. Okay. Now move on to the next. What is the given data? Average effective overburden pressure on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. That means there is some clay layer. On this clay layer, they are saying that it is subjected to a pressure of 150 kilopascal. Fine. And what they are saying still, and it is of 10-meter thickness. Okay, fine. And what they are asking, consolidation test on undisturbed sample. So undisturbed sample is taken from this side, and if they are tested, it is observed that void ratio is decreased from 0.6 to 0.5 by increasing the stress from 100 kilopascal to the 300 kilopascal. Then what we have to find? We have to find out the initial void ratio. So how to find the initial void ratio here? So if I know the change in void ratio because of the change in effective stress, which formula do you think it will be applicable? Compression index. Compression index can be written as, that will be equal to the change in void ratio to the log of sigma 2 by sigma 1. Nothing but effective stresses. So for these two, can I find CC? Nothing but what will be my change in void ratio? 0.6 to 0.5. That means 0.6 to 0.5 divided by log of, what is the value? Sigma 2 dash. What is the sigma 2 dash? 300 divided by 10. Then if you are solving this, we will get this value as around 0.2096. Right? So this is what by comparing the 0.6 and 0.5. Now what about 150? 150 is in between 100 to 300. So you can apply the same relation either by considering like suppose if I understand initial void ratio 0.6, 0.5 corresponding to 0.6 void ratio, what is the stress? 100 corresponding to 0.5, 300. Now where we need? We needed 150. If we needed 150, what will be your void ratio? Or don't think that as it is in the middle, directly think that it is a 0.5 or something. But I can say that this void ratio will be in between 0.6 to 0.5. Then how can I understand? Suppose if I take these two, I know that my void ratio will be less than 150. So what will be my compression index? 0.096. That will be equal to, what about the change? 0.6 minus, let us say initial I am talking about E0 divided by log of, what is the value? 150 divided by 100. That's it. So if you solve this, we will get this void ratio is around 0.56 or something. So this is what the problem based on the compression index related. Okay. Now move on to the next. What they are given? The natural void ratio of saturated clay strata 3 meter thick is 0.9. That means there is a 3 meter layer. For that, what is the void ratio? 0.9. The final void ratio of the clay at the end of consolidation, that means at the end of consolidation, this is decreased to be 0.71. What they are asking? They are asking us to find the consolidation settlement. So for here, you have to recall the formulas, that is delta E by E. That will be equal to delta H by H1. All these relations we have seen in the class. So what is the change in void ratio? 0.9 minus 0.71. What is initial void ratio? 0.9. Here delta H is nothing but a consolidation settlement divided by, what is the initial thickness? 3. That implies, then what will be your settlement? Just solve this equation and you will get it. So the settlement happen, if you solve this, you will get it as around 0.63. As this is substituted in meter, so the settlement is also in the meter. Now these are also the problems based on the compression index, volume compressibility, and also based on the relationships between the void ratio. In the next video, let us solve some more problems. Thank you.